multiplying monomials. Okay, we're not gonna take a test on chapter 6. We're gonna combine it with chapter 7. This is the first of chapter 7. Multiplying monomials. A monomial, okay, is a number, a variable, or a product of a number and one or more variables with non-negative integers. Okay, it only has one term. You need to know a constant is a monomial that is a real number. It's just a plain number. Okay, like 3 or 5. Okay, any questions? So what you need to do is look at the definition of monomial and see if these numbers, these terms fit. Is 10 a monomial? Monomial. Yes. Remember, a constant was just a plain number. It is a monomial. So it's yes.
So all the even ones are...
F plus 2, is that a monomial?
Yes.
No, it's not. Monomials don't have addition. Okay? This is two terms with addition. Monomials don't have that. Okay? It's either a number or variable or multiplication of a number and a variable. Not an addition problem. It also has more than one term. It's always one term. H squared, is that a monomial? No. Yes, it is. Let's read the definition of monomial. A number, a variable, or a product of numbers and one or more variables. Okay, with non-negative integer exponents. Does this have a non-negative integer exponent? Yep. Yes, it has a positive exponent. J? Yes, that's a monomial. Negative x plus 5? No. 23abcd squared. Yes, it's a product of a number and variables as long as there's not a negative exponent. What about xyz squared over 2? This is yes. It's a product of variables, okay, as long as the denominator is a constant. Okay? It's okay if the denominator is a constant. However, MP over N is no, because you cannot have a variable as a denominator. You can have a constant, but not a variable.
So no division, basically?
Yeah, there's division, but it just can't be with variables. Okay? And also, let me kind of explain it. Okay? N as a denominator, N1 can also be written like this, which we're going to talk more about. Okay? But this is the exact same thing as MP over N. MP n to the negative 1 power. Negative exponents just flip it down and make it a denominator, which monomials can't have a variable as a denominator. So, and they also can't have a negative exponent. So that's why this is a no. Write this down. Alright, you just need to know this. Your base is the first number, is this number is x. The exponent is the number written as they call it superscript, which is just a raised, it's raised up from the original. Okay, so the base is x. My exponent is 3. So I would call this x raised to the third power, or also call it x cubed. All right. Write this down. All right. So today we're going to learn how to multiply monomials. All right. We have b cubed times b to the 5th. When we do that, here's the rule. B stays the same, b doesn't change. All we do is when we multiply bases, we add the exponents. So 3 plus 5 is 8. So b to the 8th power.
So you would have times it?
No.
What lesson is that?
So remember the rule. When we multiply bases, b to the 3rd times b to the 5th, we add the exponents. So x to the 4th times x to the 9th. We're multiply bases, so we add the exponents. 4 plus 9 is 13. Okay? Let me give you an example. Okay? Let me show you why it's this way. Let's say we have 2 squared times 2 to the 3rd. According to the rule, what would the answer be? 2 to the 5th. Okay, we add exponents when we multiply bases. Let's see if that's right. Let's split out 2 squared and 2 cubed. How many? Nope, that's supposed to be 2. How many 2's do I have right there?
2, 4, 6, 8, 10.
1, 2, 3, 4, 5. That's why this rule works. Okay, when you multiply bases, you add the exponents. Write this down.
7 plus
We
12
have
would do
we have
12.
6n cubed times 2 into the 7th. We're multiplying bases, so I multiply everything that I can multiply. 6 and 2. What is 6 times 2? 12. Then what I do is I multiply n cubed and into the 7th. When I multiply bases, I do what? Add exponents. So that's my answer. 12 into the 10th power. All right. What the book does, they write this out. They split everything up. They do this. Okay. I'm not going to make that required as long as you can work it out in your head. Okay. Which into the 3rd times into the 7th is 3 plus 7. Okay. Let's do this one. 3p t cubed times p cubed t to the 4th. So I take 3 times 1, which is going to stay as 3. I take p and p and p cubed, which what is that? P to the 4th. Remember, when you multiply bases, you add exponents. T cubed and t to the 4th becomes what? T to the 7th. When I multiply bases, I add exponents. B cubed raised to the 5th power. Now, the problem before, we call that power of products, or product of power, excuse me, and that's all we did was we added the base, or added the exponents. Now we're raising a power to a power. A power of a power, when we do that, we multiply 3 times 5. So this is b to the 15th power. So when you raise a exponent to an exponent, you multiply. Here you've got 2 cubed, raise the 2nd power, raise the 4th power. All you do is multiply all those. 3 times 2 is 6, 6 times 4 is 24. Now in some of these you might have to work out, which if you did, you would find that 2 raised to the 24th power is 16,777,216.
Did you figure that up in your head?
All right, so we did product of powers. When we multiply bases, we add exponents. We did power of a power, which means you just multiply exponents. Now this is what we call a power of a product. We're raising product to a power, which all you do is you raise each term, each variable, to that power. So a to the n power times b to the n power. So let's raise negative 2xy cubed to the 5th power. So you have negative 2 raised to the 5th power times x to the 5th power and y to the 15th. You're raising the power to a power, so you multiply. 3 times 5 is 15. Go ahead and work out negative 2 raised to the 5th power. Negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. 4 times 4 is 16. 16 times negative 2 is negative 32. X to the 5th, y to the 15th. Now, there's something I want you to notice. Negative 2 is in parentheses here. And it's important that because it was already in parentheses, when you raise it to a power, you keep it inside parentheses. Because later on, you'll find that if there's not parentheses here, this is not negative 2 raised to the 5th power. This is minus 2 to the 5th power, which would still be negative 32. But let me show you this. Negative 2 to the 4th power and negative 2 to the 4th power. Let me show you what they come out to. This is 16. This is negative 16. Everybody see the difference? When it's inside parentheses like this is, you include it. You do negative 2 times negative 2 times negative 2 times negative 2. When it's outside parentheses like this is not included with 2 to the 4th power. This is actually minus 2 to the 4th power. So you do 2 times 2 times 2 times 2, and then you have a minus sign out in front. So that's the difference. Make sure if it starts out in parentheses, you keep it inside parentheses, because inside parentheses is not the same thing as outside. All right? Any questions? All right, what we're asked to do is simplify this expression. So what I want to do is I want to work out everything I can possible. First step I'm going to do is raise everything in here, raise the second power. So 3 squared, x squared, and y to the 8th power, because 4 times 2 is 8. The next step I'm going to do is raise everything to the 6th power, because this is supposed to be raised to the second power, which is raised to the third power. So I'm going to raise everything to the 6th power. Okay? So 3 squared, x squared, y to the 8th. Negative 2 to the 6th power, and y to the 6th power. Is everybody with me? Okay? So then you work out 3 squared, which is what? 9. 3 times 3 is 9. Negative 2 squared. This is inside parentheses, so negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is positive 64. Y is 6. Alright? So we're multiplying all of this. So 9 times 64 is 576. X squared, there's not any x squared, so we just leave it. And we multiply y to the 8th and y to the 6th. When I multiply bases, I add exponents, so that gives me y to the 14th. There's my answer. I'm going to raise everything here to the third power. So 2 to the third power, g to the third power, and h to the 12th power. Then I'm going to raise everything in here to the 6th power. I'm going to combine 3 and 2 and raise everything to the 6th power. So negative 2 to the 6th power. G to the 24th power, because I wrote 4 times 6 is 24. And then h to the 6th power. So now what I'm going to do is I'm going to move everything around. I'm going to write the like terms together. 2 to the third power, okay, is 8. And I'm going to times it with negative 2 to the 6th power, which is 64. I've got g cubed times g to the 24th power. And then I've got h to the 12th power times h to the 6th power. 8 times 64 is 512.
Okay. But I thought you didn't get G to the 27th.
G to the 27th power, because you add 3 and 24. When you multiply bases, you add exponents. So we've got g to the 27th.
H to the 18th.
And then you do h to the 18th. Because 12 plus 6 is 18.